What's up, everybody? Hope you're all doing well. It is now Tuesday morning, or whenever you're seeing this, and we did histograms yesterday. Gotta say, a couple of you tried to get on. I think I figured out and got down to the point who tried to get on to the morning meeting. I hope more of you can join me. I'll continue to try to do that. I know it's early, 9 a.m., especially in this distance world, and I'm making this video Monday afternoon, and many of you probably got word that Governor Murphy made the decision to not have school the rest of the year. I'm kind of a gut punch to me. I'm still down about it. Not that, to me it didn't make sense because, it does with the number of kids we have in school shoulder to shoulder, but, I was still hopeful. Hey, we're going to make the best of it. That said, take advantage of the social time. I mean, the virtual social time that we can have together. And that, even if that's a meeting, even if before I press record, we just get on and not talk about math and just hang out for a little bit, and you could tell me about the TikToks you've been making. So anyway, that said, let's get to this. Or, you could tell me about all the video games that you guys are crushing each other on. I'm sure Dennis is crushing everybody on the video games. No, Kevin's probably not. Nah, Matt's probably killing people on it. Or who knows? And I know Ava is probably crushing it on the basketball courts, even if it's virtually or real, in reality with Abby. Who knows? All right, so moving right along. Box plots today. We did histograms yesterday. Histograms are one way to visually represent data. Box plots, another way to visually represent data. All right, so with that said, you got a list of data right here. And this is home runs hit in 2010 by Major League games played at home. All right, so they like to hit home runs in their own park. All right, we're gonna make a box plot from this. And to make a box plot, we need to do something called a 5-number summary. What's a 5-number summary? It's basic, and it's all on your calculator. Got to find the minimum, first quartile, the median, the third quartile, and the maximum. Now, I happen to take all these numbers, and for time purposes, and this is what takes time, I happen to put them all on my calculator already. They are in L1 of my calculator, starting with 146, and you can rewind and see that that's the number. But I guarantee you all the numbers are on this list, and you could continue to go down, I go down, I go down, I go down, and so on and so forth. You could see that. So I'm going to hit Stat. I'm going to hit Enter. I'm sorry, I'm going to go over to Calc, and I'm going to do 1var stats. And I'm going to make sure that I'm doing things on L1. Now, notice there's still a frequency list because that's what we talked about yesterday. I am going to delete L2. I do not want any frequency lists for this, just L1. Okay, I want to do 1var stats on L1 and L1 alone, so no frequency list. Hit calculate. And there's my mean, 78.46. S is my standard deviation, 23.58. But I'm not interested in those this time. I'm interested in the 5-number summary. So scroll down. The minimum is 35. Q1, the first quartile is 63 and 73. Third quartile is 98. And the max is 146. So let me go back to my box plot screen, and I'm going to enter that data in right there. The minimum is 35. Then first quartile is 63. Median was 73. The third quartile was 98. And the maximum was 146. This worksheet happened to have this already prepared, and what you do is you draw a number line. Make sure when you draw a number line, and make sure your numbers are evenly spaced. It looks like they did it by ones from 30 all the way up to 150, really close together. So here's my 35 right there. Actually, what I do when I make a box plot, I start with the median. The median is 73, and 73 is right here. 73, start with the middle line. Then I do my first and my third quartiles next. 63 is right here. I actually write the numbers right above it. 98 is right there. Then, once I draw my median, my first quartile, my third quartile, I draw a box, and you can see I'm doing that. I'm doing it messy for a reason. I want you to see what I'm doing. That is the box of a box and whisker plot. Then I draw a little line by the minimum, and then a little line up here, 146 by the maximum. And then with straight lines, I connect the min and the max to the box. And those are called the whiskers. And believe it or not, congratulations, you've just created a box and whisker plot. Done. That's it. Lesson could end right here. But don't turn off the video just yet. Okay, what does a box and whisker plot actually represent? It represents a lot. Now, this can be broken down into 4 regions. The first region is the first whisker. Believe it or not, this represents 25. Let me use a different color pen. Let's go to comments here. Let me just have this down right here. Comments, and I'm going to just get this set up. Pardon me for just 1 second. Let me erase what I wrote right there. And let me use a different color pen. I'll go to blue. Okay. This first whisker represents 25% of the data. This box right in here represents another 25% of the data. This box here to the right represents 25% of the data. And this box, or this whisker over here, represents 25% of the data. What does that mean to you? It means this. Suppose there are, how many numbers here? There are 30 numbers, but let's even suppose there's 20 numbers, just because it's easy to cut 20 in half and quarters. Suppose there are just 20 numbers right here. A quarter of 20 numbers is 5 numbers. That means 5 numbers would be right here in this region. 5 numbers is really condensed in this box to the left, this left-hand box. 5 numbers are a bit more stretched out over this right-hand box, and 5 numbers are really stretched out over this whisker. It makes it more comprehensible when you think about it like that, because then it gives you an idea as to the shape of the data. What shape would this data have just by looking at the box plot? Do you see how the data is more stretched out on the right half? And remember, in statistics, we don't say stretched, we say skewed. So if the data is more stretched to the right, it is likely skewed to the right. And you could tell that just by looking at ranges right here. The range of the lower half is the median minus the minimum. So 73 minus 35 would be what, 38 numbers? What's the range of the upper half? That's the maximum minus the median. And the maximum minus the median is 73. Just numerically, you could see the data is more stretched out to the right. So the data is inherently skewed to the right. Now, there's one thing that I do, and I tell my statistics kids not to do. I don't worry about the range. I worry about just this middle box. Because answer this at your own houses right now. What might affect this whisker here on the top and this whisker here on the bottom? What might affect those tails? Outliers. Oh man, I don't know who said that, but great job whoever did. Outliers can affect those. So when you look at a box and whisker plot, focus primarily on the box. Look and see where the box is stretched out. If the box is stretched out to the right, it's skewed to the right. If the box looks fairly symmetrical, it's symmetrical. If the box is stretched out to the left, it's skewed to the left. All right, so we talked about that. The box can be extended by whiskers. And so we talked about percentages already. I'm even going to write that. Talked about. Hey, we talked about it. What measures of spread can be determined from the box plot, and how are they found? Calculate each measure. So we can definitely calculate the range, which is the max minus the min. Oops, sorry, minus the min. I'll never get used to writing on the screen very well. We can actually also calculate the interquartile range, which is Q3 minus Q1. In the table, 146 appears to possibly be an outlier. Determine if 146 is an outlier. All right, so this comes from the day 2 lecture. The outliers are found by these computations. You take Q1 minus 1.5 times the interquartile range. And you take Q3 plus 1.5 times the interquartile range. So this is from our day 2 notes. I guess the first thing we should do is find the interquartile range. The interquartile range is 98 minus 63. And 98 minus 63 is going to give me a value, and that is 35. So if I go back and use a red pen just to keep the colors vibrant, I am going to take 63 minus 1.5 times 35, And I'm going to take 98 and I'm going to add 1.5 times 35. And I'm going to get values. And let's see what they are right here. So I'm really interested in, I don't think that we're going to have many values below 63. Are there many, are there going to be many outliers below 63? I don't think so. Maybe 35. So to be honest, I could have an outlier there. So let's find out and let's see what it is. So 63 minus 1. Oh, sorry, buddy. Let me erase that right there. No. Here we go. Let's erase. There we go. And let's get the pen back. 1.5 times the interquartile range, and we'll write that in right there. All right, so let's go to the calculator. Let's do second quit here. And I will do 63 minus 1.5 times 35. And I'll do 98 plus 1.5 times 35. So anything falling below 10.5 is an outlier. Nothing there. The smallest value was 35. Anything falling above 150.5 is an outlier. So 10.5 and 150.5. All right, so 10.5 and 150.5. So is 146 greater than 150? Is 146 greater than 150.5? The answer is no. So no outliers. There are no outliers here. All right. And so the mean is about 78.5. Explain why the mean is greater than the median. Oh, we talked about this yesterday. If the mean is greater than the median, that is a big indication that the data is skewed to the right. Remember from yesterday's lesson that the mean always gets pulled in the direction of the skew. All right, so what about home runs hit in away games? There is the data that represents all of the home runs hit by the same teams in away games, 30 pieces of data, and it asks for the same 5-number summary. So I don't know if you noticed, but on my calculator, I also had data in L2. I happen to have this already prepared as well. So I'm going to go Stat. I'm going to go over to Calc, hit Enter, and I'm going to make sure that I hit second L2 this time. I want to do 1-bar stats on L2 and go down to Calculate. And there it is, and I'm going to arrow down, and I'm going to do my 5-number summary on L2. Let's do it right now. All right, and so there it is. My minimum is 45, first quartile 65, median 74, third quartile 83, max 113. So let me go back to my sheet. Let's fill in that data. Let me scroll it right down here. Let's do our 5-number summary. So 45, 65, 74, 83, and 113. All right, so they happen to already give you the interquartile range right there. So if I do, I'm just writing it out, if I take 65 minus 1.5 times 18, I'm going to get a value of 38, just to save some time right here. If I take 83 and add 1.5 times the interquartile range, I will get a value of 110. So look at this right here. How many values are above 110? I see 2 values. Those are the only 2 values right there that are above 110. So we actually do have 2 outliers here, don't we? We have 2 outliers. So 111 and 113 are indeed outliers. Oops. Okay. So this box plot is the one from example number 1. Let's use the 5-number summary. Let me zoom out a little bit so we could get it all in one picture. Oh, is this frozen up on me? Why is this not zooming out? All right, let's just try to pinch. There we go. So let's use the data right now and make another box plot. So I always start with the median. The median is indeed 74, which is right about here. 74. Then 65 is my first quartile. 83 is my next quartile right here, third quartile, 83. Make my box. Then let's do the whiskers. The first whiskers at 45. My whisker right there. And my other whiskers at 113. I'll do it right there. And there's my box and whisker plot for this away games. Done. Look at it and see it how it compares to the home game box plot. You can see how in the home game box plot, the box is very stretched out to the right, so you could see how it is skewed to the right. Look at the box in the away game, and look at the whole box plot in general, box and whisker plot, but the box in general is fairly symmetrical. All right, so I'll write this away game box plot is fairly symmetrical. And compare the measures of center. Are the medians roughly the same? Yeah. Medians roughly the same. And how about the spread? Both the box and the whiskers are much less spread out. So the away games have much less spread or variability. And that's it, everybody. That's how you make a box plot. Just for kicks and giggles, if you're really curious, I want to show you something. If I hit second and y equals, these are called stat plots. And if I hit enter by stat plot number 1, you could turn it on. And there's all these. There's dot plots, there's line graphs, there's histograms, and then there's 2 types of box plots. If you go to the box plot with 2 dots, that shows outliers. So I happen to make L1 for the first box plot, and for the second box plot, I put L2. So if I go to zoom and go to number 9, which says zoom stat, that means it plots stat plots for you. Hit 9. It'll plot both box plots side by side for you. Look at that. There's the box plot stretched out to the right, and here's the fairly symmetrical one, and there are even the 2 outliers right there, the 2 dots. It's pretty cool, isn't it? Hey, bad thing about this is you have no idea what is on the x-axis. It's just an arbitrary x-axis. So do not use your calculator as a general resource. Draw a number line with numbers and make sure that you do that. All right, everybody. I hope this helped, and ask questions if you have them. Bye.